everyone, and welcome to this new video. So in today's video we're going to discuss a topic of solving problems using Python, part 1. Okay, so let's get started with our very first problem, and it is about printing the sum of all even numbers from 1 to 10. So what does an even number means? An even numbers mean it is any number that is exactly divisible by 2 in itself, okay, by 2 and itself and others. So the number should be divisible by 2. An even number is any number which is exactly divisible by 2. So what do we have here? So in order to do that, we need to go through a loop. In Python there is many methods, so today we will discuss 2 methods. Okay, so on this loop we need to select the even numbers. So for example, 2 and 4 and 6, 8 and 10, those are the even numbers from 1 to 10. Okay, and in order to do that we do have several methods. Okay, not all the methods are the same, but there is several methods. There is, for example, 2 methods. Let me show you on this example. Okay, so there is this method. The first method is it is a range from 2 to 11 with the step of 2. So what does that mean? It means that we are going to only go through only the 2, 4, 6, 8 and 10 numbers. We don't need to go through all of them. Then this is also, okay, let me show you. This is the first method. This is the method 1. Okay, so then there is the second method, which is a little bit more computational power taken. So it's consume more power. So this is the second method for num in range from let's start with the 1 to 11 with the step of 1. Okay, with the step of 1. So in order to do that, let me show you the total plus if we need here a condition. If num modulo, we need the modulo also is divisible by 2 is equal to 0, then we will add the number. So if it is an even number, we will add it plus equal num. So let's not forget, this is the total. We need this variable to store the addition of the numbers. So in order to do that, and then we will do the same thing. We'll copy this, and then we will paste it over here. Method 2. So those are 2 different methods, but the first one will take less computational power. Second one will take much more. Okay, and it will get challenging through many things. Okay, so as you can see here, they are printing the same result, 30 and 30. So let me show you also this. So for example, for E in range, let me show you how the program works. For E in range, 1 from 1 to 10 with the step of 1. In here, we need to include the 10 because it is important. It is included on the exercise. So let me print the num, print E, and then we will do the and equals this mark. Okay, and then let me show you how program works. Print /n. What does this range, the step, what does step means? So for E in range from 1 to, this one is from 2 to 11 with the step of 2. So we will print here only E with the end of okay, so let me show you this. As you can see here on the first method, let me swap this for you in order to see much clearer. in order to make it clear for you. So the first method went through the iteration of 2, 4, 6, 8, and 10. As you can see here, 2, 4, 6, 9, 8, and 10. But the second solution went through all the numbers, and there was a condition, so it will take a lot more computational power, and this is not good sign. Okay, so always the first method is faster, it is less expensive in computational power usage, and a lot more effective. But the second method took a lot more computational power. Okay, so those were the two solutions, and I prefer the first one. Okay, feel free if you, because the second one we use the condition if, and there is more challenges solving this problem. Okay, so let's continue with the second exercise. So the second exercise, what does it say? It says to check if a given string is palindrome. What does palindromes mean? It means that it reads same forward and backward. Okay, so for example, this word level, it reads same way backward and forward. So we need an algorithm that would go through both sides. So for example, the first one would check the first letter, and the other would check the last letter and combine. If they are equal, it's continuous. So for example, L is equal with L, and then the E is equal with E, and then the V, there is no other thing to compare it with itself because it is on the center. So let's read this. For example, level is this word reads backward and forward, same as you can see. Okay, and there is the second example, which is hello. Hello doesn't read the same way backward and forward. So we will only check the first letter and the last letter. If they doesn't read the same, so we will skip it and we would say that this word is not palindrome. So let's check the code. So let's hide this one over here. And here is second, check if the string is palindrome or not. So in order to do that, we need a function, okay? So here is the very first solution. We need a function is palindrome. So what does it mean? So we would get a string, for example. In here, we will put, for example, level. And as you can see, level is palindrome. So what does this code do? We will get an input with text, and then we will check through calling this function. Okay, this function is really important. So let me zoom this for you. Okay, now you can see much clearer. So as you can see, this function, what does it do? It would check. So what does this do in a nutshell? So for E in range, so let me make another function. The function is palindrome from 2. So what does this do? So let me put the parameters, text. I will show you. So for E in range, len text. I will do this one. If so, if text the E of E, text of E equals text of E of len text. I make it a little bit complicated, minus E. And then we will check equals checker equals 1. Okay, so we put this variable. So there is here two cases. So there is this one over here, which means that there is the numbers are 4. So we don't need to check on the middle number. And on here, hello. So it is the same thing. So for example, there is two cases. So hello, there is for example this other word. There is two words. There is the words sum that is divisible by 2, and there is the words that have 2 that are based on 2, and there is the words that are on 3. So for example, both those examples are not 2. Okay, so we need to check also on the 2. So there is this solution if checker. So for example, this checker, if checker equals 1 isn't equals 1 is different than 1, and then here we will return 0. If okay, so we went through else we will check we will also return 0. Okay, so what does this mean? It means that the number is not palindrome. Turn 1. So this is simple checker equals 0. So let me test this second solution that we have made. So in order to test it, we will do something like this. Okay, so let me show you. Okay, the level. So in here, it's oh, okay. I made infinite loop. Okay, so the infinite loop for in range and text. If text of I equals text the length I minus 1, checker equals 1. Oh, I don't see the problem. Right. So let me retest it another time. Sorry. I don't see the problem. Oh, level. No. So, okay. Now we got some results in. Okay. Oh, okay. So the problem is here. Minus E. So what does this mean? So the length of text. So for example, the length of the text minus E. So for E in range. Yeah, I don't see minus 1. Okay. Because it starts with the okay. Now we do have results. So let me show another example. For example, hello is not a palindrome. So yeah, now we got the results. So let me show you another. So in here, why did that make minus 1? Is only to check on it, okay? Because, for example, the length of the text is, for example, of level is 5. So it will go and check for the array of 5, but the array here would start with 0, okay? So it would directly check for the 5, and then the 5 there is not, and it would cause a problem. So in order to avoid this problem, we add here a minus 1. This is also another solution, and it will consume less computational power than the first solution, because the first solution is going to inverse the string, okay, and it would take a lot of computational power, but the second one won't take a lot of computational power, okay. So yeah, so okay, so this is could get better, okay. it would get better. Why? So for example, let me test another word. H-E-E, hash. H-E-E, hash. So is a palindrome. Let's put another H-E-A-E-H. This is another palindrome, okay? So it works just fine, okay? So this one over here could be improved because it will get twice backward and forward. So we don't need this. So for example, for E in range, length divisible by 2. Divisible by 2. This will a lot will be H-E-E-H. So example, divisible by 2. So we need to put this integer, okay? H-E-E-H is a palindrome. So H-E-A-E-H. So let me show you also this is a palindrome. So this one over here is better than the previous one. So let me show you this, okay? Let me copy this. So this is the first, the second solution. And then there is this. This is the first solution. So this is the first solution. It will go through all the letters, okay? And then the second solution, it would go through all the letters also. So this one is going to take a lot of computational power. The second one is also going to take less computational power, but it's also consume a lot of computational power. And then there is the last one. The function is palindrome 2. It won't take a lot of computational power. Okay, so the three of them work. So yeah, I guess that this is it for today. So we make two examples. Okay, the sum of all even numbers from 1 to 10, and then there is the check if a given string is a palindrome. So this is a part of this series of solving problem using Python. So I really hope you've enjoyed this series. I will let the links of this series down on the description below. I really hope you enjoyed the series. Thank you for watching, and bye bye.